see more and more are taking their seats, which is great. Welcome, everyone. Welcome. Good morning, good afternoon, good evening, everyone. Wherever you are in the world, welcome to the launch of Land and Carbon Lab. I'm Craig Hansen, Vice President for Food, Forest, Water, and the Ocean at WRI, the World Resources Institute. And I'm going to be your MC for today's event. Anchored by a grant to WRI from the Bezos Earth Fund, Land and Carbon Lab will connect two communities. On the one hand, we have scientists and technologists working at the frontiers of Earth monitoring and the data revolution. On the other hand, we have the decision makers who influence the front lines of land management, ranging from governments, companies, and financiers to NGOs and civil society. Connecting these two, the lab supports development and deployment of global land monitoring capabilities that will create unprecedented insight into what is happening to the world's land and its associated carbon at any point on the planet, at any time. Today, you will hear about the who, what, when, where, and why of Land and Carbon Lab. You will see a sneak preview of revolutionary new data sets being developed by some of the lab's founding partners. You will hear video statements from some of our collaborators who represent those on the front lines of land use decisions, ones who need what we're developing in order to conserve, restore, and sustainably manage the world's land and its land-based carbon. So get ready for a whirlwind event. But before we get started, I have 4 housekeeping items. First, this event is being recorded and will be available afterwards on WRI's website. Second, we offer simultaneous translations in English, Spanish, French, Portuguese, and Bahasa. You can find the language button at the bottom of your screen. Third, if you experience any technical difficulties, please contact our hosts in the chat box and they will do their best to help. And finally, we do have a packed agenda and a very large audience, so we won't have time for a live question and answer session. But if you do have questions, feel free to submit them via email. My colleagues will share that email address in the chat box. Now, it's my pleasure to introduce to you all Crystal Davis, Director of the Land and Carbon Lab at WRI. Crystal, the virtual floor is yours.
Thank you, Craig, and thank you to everyone for joining us today. Before I officially introduce you to Land and Carbon Lab, I'd like to tell you a short story about how I came to be here today leading this new initiative. My journey began in 2014 when WRI, University of Maryland, Google, and other partners launched Global Forest Watch. For the first time ever, anyone could go online, zoom in literally anywhere in the world, and see a logging road cutting through a national park in Peru, or in this case, a palm oil plantation devastating a forest in Indonesia. We believed that if people knew exactly when and where deforestation was happening, they would be more empowered to stop it. And I am really excited to say that finally, 7 years later, we have hard quantitative evidence that better monitoring does make a difference. In 2 separate journal articles published this year, researchers found that when people are empowered and incentivized to use cutting-edge monitoring tools like GFW, we see a measurable and statistically significant reduction in deforestation. So why then is the outlook for tropical forests still so bleak when we have more monitoring data and technology at our disposal than ever before, and more people are using it effectively? In my time leading Global Forest Watch, one thing has become increasingly clear to me. It is necessary, but not sufficient to know where deforestation is happening. We also need to understand the broader land use dynamics that drive deforestation, like the expansion of agriculture, mining, roads, and settlements. In short, we need to see the bigger picture. And that bigger picture shows us that the world is facing unprecedented competition over a finite amount of land on Earth, and that competition is only intensifying. The global population is expected to reach over 10 billion people by 2050, and that includes a growing middle class. Demand for land-intensive commodities are expected to rise accordingly. And even if we assume that agricultural yields continue to improve consistent with historical rates, and that alone is a pretty big assumption, we will still need to expand the global footprint of agriculture by an area twice the size of India by 2050. And since we don't exactly have lots of vacant, underutilized land just sitting around waiting to meet these needs, we can assume that this expansion will come at great cost to the world's remaining forests, savannas, wetlands, and other natural ecosystems. Yet we also know that if we want to keep global warming below 1.5 degrees Celsius, the IPCC has warned us that we cannot convert any more forests into agriculture. In fact, we need to go further than ending deforestation. We also need to restore another 600 million hectares of land back into forests to pull more CO2 out of the atmosphere. And we need to do all of this while also feeding and improving the lives of over 10 million people. So it is truly an overwhelming challenge, and it requires a massive shift from business as usual. And that is how my journey has taken me beyond the forest to leading the Land and Carbon Lab. This new initiative arises in response to this global land squeeze and out of a new belief. We believe that if we are going to have any chance of meeting the world's climate, biodiversity, equity, and development goals, we will need a more complete and a more detailed understanding of how we're using the world's finite land. So whether you are working on combating deforestation, like I was, landscape restoration, wetland conservation, or agriculture, we are all shareholders in the world's land. We need to step out of our silos and start working together. So as a first step to bringing us together, Land and Carbon Lab is convening leading scientists and technologists to build a comprehensive global land and carbon monitoring system. Within 2 years, we aim to be monitoring all forms of land cover and land cover change, plus associated terrestrial CO2 emissions and removals. And we aim to do this at a global scale, year on year, at 10-meter resolution. So as you can imagine, it's an incredibly ambitious goal. So fortunately, we have already gotten started. You're going to be seeing a sneak preview of several brand new data sets today from the amazing scientists who are behind them. Now, no one has actually monitored all the world's land at the 10-meter spatial resolution we are proposing. So I want to take a moment to quickly explain why resolution matters so much. Here we see a land cover map derived from a satellite image taken at 16-kilometer resolution. All we can really see is green, so we classify the area as forest. And based on what we know about the typical biomass of a forest, we can estimate carbon stocks at about 170 megatons. Now let's look at the same area, but using 1-kilometer satellite imagery, we can produce a much more detailed land cover map. So now we see it's not all forest after all. We see grasslands, we see croplands, built up areas, and these have lower carbon densities. So now we've revised our carbon estimate to 120 megatons. And now again, zooming in on the same area, but at 300-meter resolution, we can see even more detail. Our carbon estimate drops even further to 50 megatons. So what will we see at the 10-meter resolution Land and Carbon Lab is creating? How radically will this change our understanding of carbon stocks and flows across a landscape, let alone the entire world? And how will this new knowledge change our climate strategies going forward? I want to be very clear that we are definitely not starting from scratch, and we are not doing this alone. Our goal is to harness and amplify the amazing science and technology that's already out there, so we can figure out what gaps remain and help fill them, and also foster scientific collaborations that accelerate the pace of innovation across the board, because we really don't have any more time to lose. We are also not proposing to build a big new data platform. All the data generated by Land and Carbon Lab partners will be housed in the existing Resource Watch and Global Forest Watch platforms. And we will make all of that data freely accessible to any third-party website or app through our API. Because our vision is that these data will support a vast ecosystem of targeted tools and apps that have been created to serve specific users and their use cases. Because as we have learned, often the hard way, there is no such thing as a one-size-fits-all data tool. And also, even though there are more and more tools out there these days, it's important to remember the tool is only as good as the data and methods that go into it. So now in the final minutes of this presentation, I want to take a step back from talking about data and monitoring. And I want to be very clear. Data does not create impact, people do. So for every dollar Land and Carbon Lab invests in data and technology, we need to be investing $2 in empowering the people who are best positioned to use this knowledge to create real change. And in my experience, most decision makers don't want data. They just want simple answers to their most pressing questions. And every day we are hearing about new data and new tools being launched, and this is useful, this is important work. But I also think that this avalanche of data is often overwhelming rather than helping decision makers, or it's simply failing to reach those who need it most, like the indigenous peoples and local communities who collectively hold nearly 50% of the world's land. So Land and Carbon Lab aims to change this by doing the hard work of putting the right information in the right hands to create impact. So we are now forming collaborations with organizations that are pursuing shared objectives and that are connected at scale to the decision makers we aim to serve. We really want to hear firsthand from you. What are the problems that you face? What information could help you tackle those problems? And then we want to work with you to create and iterate practical monitoring solutions that really work for end users. So you will be hearing from some of these end users today that reflect some of our first collaborations. You will hear from the NDC partnership about how countries are requesting help on monitoring so that they can meet their land sector commitments under the Paris Agreement. You will hear from HSBC about how businesses who want to invest in nature-based solutions need credible independent data to help them invest with confidence and integrity. And you will hear from people working on the ground who need better information to guide their efforts to protect and restore local lands and to get due credit for doing so. So you've heard me make two separate calls for partnership today, and that is because our ambition will only be achieved through collaboration. Land and Carbon Lab aims to be a bridge between two communities that really need to be talking to each other more. On one side, we have brilliant scientists and technologists who are working at the frontiers of Earth monitoring and the data revolution. On the other side, we have decision makers who influence the front lines of land management, but who need better information to guide their decisions and actions. We are connecting the supply side and the demand side of land and carbon monitoring to create impact, and I'm inviting you to join us. And before I go, I'd like to quickly thank the Bezos Earth Fund for their generous grant that has made Land and Carbon Lab possible. So thank you, and I will turn it back over to you, Craig.
Thank you, Crystal. You talked about the lab connecting the frontier of the land monitoring revolution with those decision makers that influence the front lines of land use. So with that in mind, let's hear for a moment about the promise of the Land and Carbon Lab for all those countries that have set nationally determined contributions to the Paris Agreement on climate change. And for this, I turn to video remarks from Pablo Vieira, Global Director of the NDC Partnership.
The NDC Partnership brings together 115 countries, developed and developing, and over 80 international institutions to support countries develop and implement ambitious nationally determined contributions, or NDCs, that help deliver the Paris Agreement and achieve the Sustainable Development Goals. Governments identify their NDC implementation priorities and the type of support that is needed to translate them into actionable policies and programs. Based on these requests, the membership offers a tailored package of expertise, technical assistance, and funding. This collaborative response provides developing countries with efficient access to a wide range of resources to adapt to and mitigate climate change, and foster more equitable and sustainable development. The NDC Partnership is built on the premise of collective action. By acting together, we achieve more. From across our membership, more than 40 countries have already requested monitoring assistance in relation to their NDC targets regarding forests, agriculture, and other land uses. What they need is what the Land and Carbon Lab will be providing. Therefore, we are excited to be an official collaborator of the Land and Carbon Lab, which is developing monitoring solutions to help us aid countries in their NDC commitments and fulfillment. Thank you very much.
Great, thank you, Pablo, for that message. It's exciting to see such burgeoning national demand with more than 40 countries now asking for engagement. And now to hear about the promise of Land and Carbon Lab for the great continent of Africa, I welcome a video message from Wanjira Matai, DBRI's Vice President and Regional Director for Africa. Wanjira.
Thank you for the opportunity to share a few thoughts. That was inspiring, Craig. As we launch the Land and Carbon Watch Lab, I'm inspired by the simple potential of what this could mean. What a privilege to be speaking today at this launch. And I imagine for a minute the amazing task ahead to monitor every tract of land on the planet. This has simply never been done. And how delighted I am that WRI will be leading this charge. There is one continent on the planet that has no greater opportunity than anything we've ever seen. There is one continent on the planet that has an opportunity to leapfrog the development strategies of other continents, and that's Africa. It has the greatest restoration potential in the world. And in Africa, we can actually demonstrate that preserving the environment and helping our people prosper actually go hand in hand. In fact, I love the adage that a healthy environment supports healthy people. Nowhere on this planet do we have an example of people having thrived by destroying their environment. Now, in 2015, I was really proud. The African Union led a move to establish AFR 100, an Africa-led audacious initiative to bring 100 million hectares of degraded land to restoration by 2030. It was African-led, which made it fantastic, and it galvanized governments of 31 countries so far to commit 128 million hectares of land for restoration. Goal was 100 million. We got 128 million. Incredible commitment. And it's quite simply an amazing movement. Countries are now poised to translate those pledges and early successes into coordinated, large-scale restoration on the ground. But even with the commitments that we've seen thus far, and with some of the great examples of restoration that have been going on, there are still some gaps. Monitoring restoration is one of those most important gaps that still remains. I have so many memories of being in the Ministry of Environment in Kenya and sitting with the minister talking about AFR 100. And then he looks at me and says, how are we doing towards the 5.1 million hectares that Kenya committed? This is a question that so many are asking across the continent, and to have the sort of actionable evidence that would make them make decisions, especially at moments like this, moments of pride, are as important as ever. And so all restoration, all AFR 100 commitments will have to be monitored. They will have to be identified. Where are these trees being restored? Where are, especially outside forests and agroforestry systems and farm landscapes, where is restoration happening? It will be crucial to monitor the success and even the challenges and failures, to ensure the confidence to those who are investing in restoration, and to build in the necessary transparency and accountability that will fuel this movement. Some of the data you'll hear about today coming out of the Land and Carbon Watch Lab are exactly what AFR has been dreaming about. I live in Kenya, where 2/3 of the country is arid, semi-arid, or desert. Imagine that. To many people, that means we only have 1/3 usable land, 1/3 valuable land. And the rest means there's nothing there. It's arid, semi-arid, or desert. But on closer examination, these crucial landscapes will come to life. Kenya's savannas are teeming with biodiversity. They're some of the most biodiverse landscapes in the world, and they present some of the most important opportunities for climate mitigation. Never before will we have seen this level of analysis and the flux of carbon involved. Never. This is groundbreaking, and the magic and true value of the savannas of Kenya and many landscapes like them around the world will come to life. I cannot wait. So sit back, and thank you all so much who are working so hard on this truly transformative journey. Thank you.
Thank you, Wanjira, for your enthusiasm for what's to come. With that in mind, let's get on to the next portion of our agenda. Here, we're going to showcase live several new monitoring approaches and data sets that have recently been developed by lab founding partners. We'll intersperse these with short video statements from users of monitoring data. So to begin, we're going to start with my colleague John Brandt, who's a data scientist at the World Resources Institute. As Crystal mentioned, we all started with monitoring trees within forests via GFW. John's going to unveil a brand new system here for detecting trees outside of forests. So John, the floor is yours.
Thank you, Craig, and hi, everyone. I'm incredibly excited to be here today to share with you our new tree cover data set that we explicitly designed to detect trees outside of dense forests. I'd like to begin by setting the stage with how we got to where we are today. In the early 2000s, our partners at the University of Maryland first mapped tree cover from space and at a global scale. This data was transformative in changing the ways that forests were monitored by enabling spatially explicit analyses of forest change year over year. In 2013, new tree cover data came out from our partners at the University of Maryland and Google. This data has been very important for assessing forest disturbance, biodiversity indices, and carbon sequestration. Since then, WRI and our partner organizations have expanded this data to include yearly loss statistics and have focused on non-biophysical data like the locations of timber concessions and protected areas. However, current land and tree cover data sets don't have high enough resolution to consistently map areas like this open canopy forest in Kouré, Niger, which is being actively stewarded and managed by its local community. Or this forest restoration project in Huila, Colombia, where the trees are too young and too small to be captured by a 30-meter satellite. Or this agroforestry system in Makueni County, Kenya, where the trees around farmland are very important for stabilizing the soil and for reducing erosion due to wind. As Wanjira spoke about just now, these kinds of tree distributions are incredibly important for reducing pressure on primary forests, for supporting biodiversity and climate adaptation, and for food security. These trees are also central to sustainable land management agenda, such as the Bond Challenge target to restore 350 million hectares of land by 2030, and supporting regional initiatives like AFR 100 and 20 by 20. Governments, investors, and restoration implementers all need better monitoring data in order to assess risks and impacts of tree-based restoration. Here's why these types of forests are difficult to detect. I don't think anyone on this call can make out where the trees are in this 30-meter Landsat image. But now with the Sentinel satellites, we have just high enough resolution data to see them when matched with the power of artificial intelligence. Here's an introduction to the data that's available now on Resource Watch and Global Forest Watch. Zooming into an agricultural landscape here in southern Chad, you can immediately see the concentration of trees in urban areas. You can see where the community woodlots are. And as we zoom in further, you can begin to see the individual trees and the clumps of trees that dot this agricultural landscape. Understanding the extent of these trees is very important for monitoring the Great Green Wall and for other restoration efforts across the drylands. It's also important for understanding and monitoring agricultural and soil health. Here in Senegal, you can see just how many trees there can be in agricultural drylands in the Sahel. If we zoom into just this one small area, you can begin to see how this data, for the first time ever, enables the mapping of these individual large trees in the drylands. Considering urban areas, this data enables very detailed mapping of urban tree cover and extent in cities for the first time. Shown here is Mexico City, where nearly a third of the city has at least 10% canopy cover. In Addis Ababa, Ethiopia, our data identifies that more than a third of the city has at least 10% tree cover. These types of analyses are incredibly important for cities that have urban canopy targets as part of Cities for Forests or other tree-based urban forestry initiatives. Turning to our last point of focus, I'd love to show you two quick examples of how this data can map fragmented forests and edge forests. Shown here is an agricultural landscape in Zimbabwe, where the agricultural clearings and the boundary trees are mapped in very high detail. You can see the individual outlines of the different farms by the boundary plantings and the trees that border them. Conserving these types of dry forests is incredibly important, and this data can help stakeholders understand where encroachment is happening and the status of conservation efforts. Shown here in Panama, as we begin to zoom in, we can see the small-scale clearings and the urban-rural agricultural gradient. As we move in even further, you can begin to see the boundary plantings the riparian buffer zones, the urban trees, and the trees on farms. Early analysis of this data done by WRI identifies more than 4 million hectares of Central American farmland having more than 10% tree cover. That's nearly a tenth of Central America, and it shows just how high the adoption rate of sustainable land management practices is already among farmers. As we zoom in, you can begin to see some of these individual large trees on these farmlands. This data set extends across 1.4 billion hectares right now, an area 50% larger than Europe. It was built by analyzing more than 30 trillion pixels in satellite imagery at a 10-meter resolution. Here's an overview of the data that we're releasing today on Global Forest Watch and Resource Watch. It's focused on the agricultural, urban, and mosaic landscapes across Latin America and Africa. It's still draft data, with the areas in green and white being available online today. And the rest of the full data set in blue will be online in January 2022, so in about 2 months. All of us at WRI are really excited for the applications of this data to restoration monitoring, to better understanding dry forests, and monitoring urban canopy and fragmented forests. Paired with existing global tree cover and land cover, it'll give us a far more comprehensive picture of the world's lands. But we're not done. In 2022, we'll expand this data to cover all non-desert areas in this map, corresponding to about 5 billion hectares and 100 trillion satellite pixels that we'll analyze across more than 1 million hours of computing. We will then work with our regional partners to develop a yearly operational monitoring system for tree cover change and tree-based restoration. This will also focus on separating tree plantations from non-managed trees so that we can understand how much of the new tree cover is due to restoration efforts versus shifting agriculture towards plantations. As you can see in this map on the left, showing a restoration project in central Brazil in the white dashed polygons, this method can locate regions of new tree growth in purple within restoration projects only a few years after planting. We're really excited to work with all of you to better monitor the world's natural resources. And we encourage you to view the Trees and Mosaic Landscapes data layer on both Resource Watch or Global Forest Watch today. Thank you so much.
Fascinating, John. Congrats to you and the team for developing a system for detecting trees in mosaic landscapes, right? Those important trees that are outside of forests, typically in rural agricultural areas. It's and the fact that you're going to come out with this data on an annual basis going forward is pretty exciting. And as you noted, it's going to be a critical underpinning of big restoration efforts that are going on right now in Africa and Latin America by collaborators like AFR 100 and Initiative 20 by 20. So congrats. Now, as an example of the importance of such monitoring that John just talked about, let's hear now from a video from Marcos Sosai, manager of the Florestar program, the State Environment Agency of Espírito Santo in Brazil. Marcos.
Olá, meu nome é Marcos Sosai, eu sou engenheiro florestal e atuo desde 2011 como gerente do programa Reflorestar, que é uma política pública que tem como objetivo
that we have as a goal to monitor the reforestation in Espírito Santo. We have 10 years of experience, and between 2003 and 2011, our goal is to incent the farmers to replant trees. And our goal is that they will not only conserve the trees, but also generate income. This implementation of the trees in the farmlands. And for one, we have been able to expand considerably, but we also have noticed other challenges. So I'd like to talk about the quality of the data that we are able to collect and the implementation of the scale that we want to implement. Recently, we have tried to monitor with satellites, but this methodology proved slow to show changes, and also hard because of the quality of the images. Also because they are not accessible and they require extensive training on the part of our technicians. So this initial, we can change this with the information that John just showed us, so that we can have more data for analysis, more precise information for the recovery of the forest, especially in the agricultural land, and incentives for the people that are doing this with us. The potential to reforestation will be able to provide new investments, and this will create a progress and intervention in terms of reforestation, and a leg forward in the progress of this initiative, especially with the rainforest, and support Brazil in the different initiatives for reforestation, like 2020, the challenge, the Bond Challenge, and the Declaration of New York for reforestation.
Great. Thank you very much, Marcos.
Muito obrigado,
It's interesting
Marcos.
to see from his comments the importance of what the data lab is providing is complementary data to data that entities at the subnational level are generating themselves. And that's part of the vision here, right? There's no, as Crystal said, there's no one size fits all. It's a complementarity of data that actually helps meet user needs where they are. And that's part of our vision. So we look forward to continuing working with Marcos and others at the subnational and national levels as we go forward. Now, as Crystal noted, it's not just trees that are important for climate, biodiversity, and human well-being. Grasslands, wetlands, croplands, and urban areas play an important role too. So the lab is looking beyond trees. And to introduce this, we're going to hear from Matt Hansen, co-director of Global Land Analysis and Discovery at the University of Maryland. Matt's going to unveil a brand new system for monitoring change in all forms of land use and land cover, which builds on his team's groundbreaking system for monitoring forest change. So Matt, the virtual floor is yours.
Thank you, Craig. Really appreciate this opportunity to build out our monitoring systems. I think we've been working on this for 25 years at the global scale. And we've done it mainly with publicly available data produced by space agencies like NASA and USGS and the European Space Agency. So before I get into the new products and what we're thinking in terms of a more holistic monitoring system, I'd like to mention that it's not possible without global public good infrastructure from the Earth observing systems. And these examples that I'll show, the example I'm going to show right now is based on Landsat. These prototype products are the first of our efforts with the Land and Carbon Watch. And it is a bitemporal 2000 and 2020 depiction of IPCC-like classes. So we've got fractional vegetation, we've got forest in the form of tree heights. These are continuous layers. We have snow and ice, water, surface water dynamics. And then on top of that, we put a couple of initial land uses, cropland, and built up, or basically settlements and infrastructure from man-made surfaces. These layers, when put together, can help us understand, as Crystal alluded to, what is going on when we see a forest be converted. What is the driver behind it? What is the land use that replaces it? So, and what other contexts or potentials for expansion are there? And so one other theme I'd like to mention is wetlands. So we have a wetland layer that I'll also highlight in our examples. And we'll build out this hierarchy of land cover and land use. For example, we're working on dividing cropland into key commodity crops such as soybean and sugarcane. And as we do this, we'll test the feasibility of annual monitoring of much finer thematic granularity in terms of monitoring land use. I'll start with zoom in, and again, this is a bitemporal look. This is year 2000. We're zooming into one of the global hotspots of the last 40 years or so, the arc of deforestation in Brazil. South America has tripled its cropland in the last 30-some years, and a big part of that has been soybean. And we look at this change, the orange color is cropland, and you can see the green color disappearing, that's deforestation, but you see it mainly disappearing to short vegetation, which is pasture. And one of the things nice about putting these layers together is that when we look at soybean, we estimate only 5% of soybean is approximate driver in terms of replacing forest. It usually backfills on established pastures. And it points out the idea of doing multi-thematic monitoring, as we understand that when I turn on the overall change matrix, this red color is clearing in the frontiers of the forest related to pasture. So pasture is displaced by the higher order land use of row crops and typically soybean and Mato Grosso. And even though pastures are intensifying, there is a big wave of expansion in the frontier forest, mainly pasture. So that's one example. And the commodities that are produced by South America go around the globe. And one of the big consumers in importing commodities is China. And China, as we know, the economy has expanded dramatically in the recent years. And if I zoom over to China, we can see a different dynamic. China has basically reorganized their population in urbanizing as they built out manufacturing and other industrial applications. And if I look at 2000 urban land use in 2020, you can see this dramatic growth in the urban footprint. This is occurring in the traditional breadbasket of China, the North China Plain. So there, cropland, they're losing cropland, replacing with a higher order manufacturing and settled land use, and importing more and more commodities to support improved standards of living, higher meat fraction in the diet, and standards of living in these manufacturing livelihoods. So you can talk about the soybean that replaces the rainforest going to China to feed pigs that are turned into food stuff. These richer diets are being supported by manufacturing to produce cell phones that are in front of us on our desks right now. So we think that a lot of the addition of the carbon dynamics, the commodity change dynamics, when we build out some of these themes, we'll be able to make linkages across geographies and look at the global dynamic. One area that is not as linked to the global economy is sub-Saharan Africa. And I'll zoom into an area of Western Tanzania. And this is 2000. Orange again is cropland. Peter Potapov, who's the co-director with me at the GLAD Lab, has a paper coming out in Nature Food. And Africa, on cropland expansion, Africa has the largest area of cropland expansion in the last 20 years, more than South America. And this is due to rapidly growing populations as the proximate driver. And so we can see this dramatic change of the loss of Miamba woodlands and conversion to croplands. And you can see the settlements strung along the roads and this build out of the agricultural landscape. Also note that this deep blue color, that is a wetland, a big wetland complex in Western Tanzania. And that acts as a brake on development unless you find technology and the resource to drain it and add more arable land to your basis. So I like this idea. I hadn't seen it before, but the global land squeeze is a really great way to put it. And if we go to another wetland in Sumatra, we can see that in this mosaic of tree cover and development and wetlands in 2000, by 2020, we have the arable, the well-drained low slope lands of the main spine of Sumatra already cleared. And then the change goes down into the wetlands, into the peatlands. And we know the carbon emission implications of clearing peatlands for land use and the introduction of fire. So again, the pathway of land use as it expands across different land forms and pressures, whether it's commodity land uses or population. In Africa, we can expect 5 out of the top 10, according to the UN, populated countries in the world to be in Africa, including Tanzania. This is the challenge we face in terms of managing things. Now, I am from Indiana in the United States. We zoom into where I am, my home region. It is all corn and soybean, kind of like Mato Grosso. Back when the European settlers came, this was 90% hardwood forest. And if you want to speak strictly about deforestation-free commodities, that's not Indiana. So one of the things I think that we really face in this global land squeeze and development is the pathway of development that was been used by the richer countries in terms of intensive agriculture, clearing of all the forest, letting some grow back through the forest land use transition, optimizing the allocation of agriculture and forestry and settlement We don't expect that to occur in other countries if we are to mitigate climate change. But it's very tough ask to look at a place like the United States in the temperate zone where the wetlands have been drained and the forests have been cleared. And that has been used to go from agrarian to industrialization to more service-based economies. And the lower latitude developing countries must sacrifice that opportunity in the cause of climate change mitigation. So this is our big challenge, is to find a way to have a fair deal to compensate countries that are going to forego that development scheme, but also don't sacrifice economic development. So how do we thread the needle by keeping economic development progressing while maintaining ecosystem services? And I think that that's the challenge that as a whole we face. And I hope that our data will at least measure the success or failure of that, but hopefully inform policy decisions, downstream scientific applications like Nancy will talk about, to measure the impacts and to measure the trends and hopefully the successes in coming up with a more sustainable economic and environmental future. Thanks.
Thank you, Matt. This is exciting, right? For the first time, we now have mapping and monitoring of all forms of land use and land cover, static as well as change over time, at a 30-meter resolution from the year 2000 to today. And you're going to move to annual and keep on doing this going forward. So in my view, this is a pretty big deal for advancing science and policy, especially for measuring impacts and outcomes regarding all forms of land. So congratulations, Matt, to you and your team. Continuing on the theme of detecting and monitoring all forms of land and land use change, it's my pleasure to introduce Rebecca Moore, Director of Google Earth and Earth Engine. Google has been a partner of WRI since the founding days of GFW and later Resource Watch. So we're pleased to be collaborating with Rebecca and her team on efforts to expand monitoring beyond forests. So Rebecca, the virtual stage is yours.
Thank you, Craig. And I hope everyone appreciated what a treat we just got watching Matt Hansen fly around the globe and expound on the phenomena and the insights that he was able to glean from this new product. Matt, fantastic. And I'm really glad that your Earth Engine application held up under your interactive pressure. Nicely done. So I'm really excited to represent Google and help kick off the Land and Carbon Lab. We have a very long time, fantastic relationship with WRI, with Craig, Crystal, and of course, Matt Hansen. And I'm going to speak a little bit about basically the cutting edge technology trends with cloud computing and AI that we think can revolutionize progress in global land cover monitoring. So this is something very familiar to everyone, right? There's tons and tons of incredible data. As Matt Hansen mentioned, it's now public, open, and free from NASA, from the European Space Agency, from a number of space agencies around the world. But this data is petabytes of data and typically ends up going onto tapes in government vaults and is not as accessible as it needs to be for deriving insights at scale. So a decade ago, we launched Google Earth Engine, and I'm going to give a quick past recap and then get us to the present and the future here. But for those who don't know, about a decade ago, we launched the first cloud-native planetary scale geospatial analytics platform and put it in the hands of scientists and NGOs to try to understand our changing planet in a way that hadn't been possible before. And the breakthrough was to co-locate petabytes of data that was streaming in to Google data centers onto the Earth Engine platform every day, and co-locate that with tens of thousands of computers with an application programming interface that was intrinsically parallel, that would take a scientist's algorithm and then run it at scale over the whole planet, potentially over decades of data, harnessing tens of thousands of computers. And Matt was our first guinea pig. Yes, it was just such an exciting, such a profound collaboration for us. Really, he was the first scientist who had the courage to try out this crazy new cloud computing platform called Earth Engine. And as I think many of you know, it led to this groundbreaking paper in Science in 2013, the first high resolution global maps of forest cover and change. And that a key was, it was 1,000 or rather 1 million hours of computation over almost 700,000 Landsat scenes. But because we ran it on 10,000 CPUs in parallel, we had the result in, I think it was about 4 days of computing, whereas on a single computer, it would have taken 15 years. So I mentioned this, I think I've mentioned this before, but it's worth noting because that's the new era that we're in now, that we can do these high resolution planet, global scale, deep time series analyses that had never been possible before. And immediately WRI realized the potential of this, and we formed a partnership to turn this into Global Forest Watch, which has been profoundly successful, I think, in terms of beginning to turn the tide on deforestation. All right, so quickly going to maybe 2 trends I wanted to talk about, and then go into the new data product that we're co-developing with WRI. So one trend is the expectation that data will be more and more timely. For some applications, some use cases, it's fine to have an annual map, but for others, you really need much more near real-time data. Matt Hansen's GLAD alerts that are powered by Earth Engine are an example of needing to have much more timely data for alerting. The GOES data set is one that updates every 15 minutes. This is a NASA NOAA satellite that is in geostationary orbit. So it's continually monitoring the same place. And every 15 minutes you get fresh data, including thermal information, so-called hot pixels. And we are streaming that into Earth Engine continuously. We get the data within seconds or minutes. And we're using that now. We're applying Earth Engine to derive near real-time boundaries of wildfires, which, as you can imagine, is quite important these days, and publish that in both Google Maps and Google Search. This is the first Google Earth Engine powered Google Search result. So this data is coming off satellite. Within a few minutes, it's ending up in a search result that's on your phone in the hands of 1 billion people, or more than that. And I think what's significant about this is that capability with Earth Engine and with cloud computing and the data that's coming into the Earth Engine catalog continuously in near real time is available to all the developers on Earth Engine who want to do something similar. All right, now let's cut to a different trend. People talk a lot about AI. I thought it might be fun to go back to the history of AI at Google, which was about 10 years ago. We were developing what was then called Google Brain, our early AI technology. And we wanted a big corpus of data to experiment on. And so we started, our first experiments were with massive amounts of YouTube videos. And the idea was, what could we discover that was common in YouTube videos? Who knows the answer? It was cats. There's a lot of cats in YouTube videos. It was one of the most popular features that we found in YouTube videos. So, all right, what if we can now take this technology and deploy it in more applications toward environmental and sustainability? So there's a project we did with Conservation International and a set of other partners for applying AI on camera trap images, millions of camera trap images, to be able to detect automatically and identify species in the wild. We have built a model. The idea was, could we do this not just on one species, but on hundreds of species automatically? And that's what we've done, which is we've trained this model by bringing in millions of labeled images that came from a set of conservation organizations. We trained up this model, and then now you can present a new image that it has never seen before, and it can classify it. So we launched this with Conservation International, Smithsonian Institution, a set of partners. It's called Wildlife Insights. It's available to anyone. The idea is you can upload an image from a camera trap, and in less than a second, it gives you a so-called prediction and the confidence in its prediction. In this case, it's most confident about this being a margay. This is now being used all over the world, many, many locations and so on. So I use this to set the stage of the power of AI for environment. Now let's switch back to our topic at hand. We know that we want to go beyond mapping and monitoring forest. We want to be able to monitor all sets of land cover types because many of them are quite relevant for carbon and so on. So we began a project with WRI about 2 years ago, I think, Craig. WRI developed a taxonomy of 9 classes, land cover classes, that were most relevant for societal benefit. Here is that set of classes. And now we have then trained a model, just as we did for species, by bringing in labeled Sentinel-2 satellite images, training up a model so that it can automatically detect and predict, so-called predict, land cover classes on new images from Sentinel-2 as they are coming in. This is groundbreaking, hasn't been done before. It takes something like 33 million machine hours to classify the entire terrestrial globe. Let's look at some examples. This is not publicly available yet, but it is coming. Stay tuned. Let's look at some examples spatially of what 10-meter resolution can do for you. Looking in New Zealand, this is the Copernicus Land Service 100-meter resolution map for that area of New Zealand. And now this is the 10-meter resolution version. You can obviously see much finer detail. Here we're looking at, I believe, Punta Arenas in Costa Rica. This is the 100-meter resolution Copernicus Global Land Service map. And this is what 10-meter resolution global land cover can look like. You can see a river, you can see urban development that isn't available in the lower spatial resolution. I do want to give a call out that we're super excited. The World Cover team has also recently launched a 10-meter Sentinel-based product. It's wonderful to have this type of innovation happening. One of the novel things about what we're doing is because we're able to do the automated analysis and land cover detection on each scene as it's coming in, we're able to detect seasonal change. For example, here, if you look at the sequencer, we're seeing the snowstorm that hit Boston in February 2021. If just wait for it, and there we go, snow. Here's a different example, the Caldor fire that recently hit my state of California. Because we're doing this in near real time and we can do it seasonally, we're able to detect the Caldor fire. Here's a final example of a recent volcanic eruption in the Philippines, and you can detect ash from that. So where does this take us? I think I just wanted to end with this sort of a dream of hope, which is we're looking here at Costa Rica. Costa Rica has been such a leader in global forest restoration. And what we just saw there was their detectable from space and shown in our in this land cover product, the significant restoration of forest in Costa Rica. So stay tuned as this comes to your favorite channel. Back to you, Craig.
Great, thank you, Rebecca. Pretty exciting stuff. There's a lot of groundbreaking developments here that you highlighted, especially with applying artificial intelligence to the Sentinel satellite images to generate kind of as it happens monitoring. I love the snowfall, and then you see the city back again. Pretty exciting, and I just can't wait to hear the forthcoming announcements in this space. So as Rebecca said, everyone watch this space. There's some great stuff coming here in our partnership and with the Land and Carbon Lab on all this. So thank you again, Rebecca, and thank you for the long partnership we've had with Google in the past and going forward. Now, Crystal talked about the power of putting data into action, right? By connecting those at the frontiers of monitoring with those at the front lines of land decisions. Now, the Land and Carbon Lab basically seeks to advance, by doing so, the conservation, restoration, and sustainable management of all the world's ecosystems and working lands to achieve climate, biodiversity, and human well-being goals. Now, we know this connection works, right? In the next video, we're going to hear from two people on the front lines about how forest monitoring data has helped protect the ecosystem that they call home. Now, our vision with the Land and Carbon Lab is to expand this capability to all ecosystems that people call home. And so I present to you Tom Buick, the Peru Program Director of the Rainforest Foundation US, and Jorge Perez Rubio, the President of the Interethnic Association for Development of the Peruvian Rainforest. Tom and Jorge.
Soy Tom Buick, el director nacional de Rainforest Foundation US aquí en el Perú. Y voy a aprovechar esta
I
oportunidad.
am the General Director of the Rainforest Foundation here in Peru, and I will share with you the experience that we've had working with indigenous communities here in Peru. So in Peru and the other countries in the Amazonia, we have more than 247 million hectares, which represents more than 30% of all of the forests in the Amazon. And I am presenting this with my friend Jorge Perez, who is the president of the Association of Development of Rainforest in Peru. So this is a question for Jorge. Why is it important to respect the rights and territories of these indigenous peoples? Hello, my name is Jorge Perez Rubio. I am the president of IDC. And the territorial rights of indigenous people in the Peruvian Amazon, it's extremely important to protect because they are the ones that provide well-being to the indigenous people. This has been the case for millions of years. That is correct. The Rainforest Foundation in the US has been investing technology, information, and putting this data in the hands of the indigenous peoples here in the Peruvian Amazon. So Jorge, how are you utilizing this data with collaboration with indigenous communities? Well, the Rainforest Foundation US organization has provided technology that are really tools that have been adapted to us. For example, the locust prop tool that allow those monitors to take photos, to set a number of coordinates in terms of those points that have been deforested. And this is part of the evidence of a case file that will be presented to the authorities so that they can intervene accordingly. So here in Orpio, something that we have done with that data is to take political decisions as well. We have planned and we have used that data to select those basins that we will be intervening based on how this deforestation is occurring.
And bearing that in mind, we have made an alliance between Worldview, World Resources Institute, Rainforest Foundation, US, in order to measure those places. So that shows deforestation where the technology is being implemented. We have seen a 52% reduction. What does this mean, Jorge? What does it mean for the indigenous organizations and the indigenous movement? Well, it has given us an independent opinion regarding the work that we've been doing among the indigenous people and the foundation, that is, the trainings, the use of technology, the patrolling that we do in forests, the presentation of information on deforestation for the Peruvian authorities, for example, the war Navy authorities, among others. All those details have been verified through a very deep and independent survey conducted by the universities, so that we can say that this is information that is consistent. It was proved that this work is serious, responsible, that the organization of the indigenous people is respected, and that is seen in reality through the reduction of deforestation. The procedure used is the best. How? What can you say about the tools and the solutions, right? The solutions are in the hands of the people and the tools too. So imagine, here we have Peru. Imagine how important it is to analyze the forest of the Amazons as a whole. It's very important to have this information because we can really take care of more than 518 million hectares in all the Amazons, in this area, that area, and many other areas. If we don't get organized strongly, if we don't have the appropriate technology, and if we don't teach the people to defend themselves better, I believe that the situation will become much more complicated. Thank you, Jorge, and I want to thank all the participants. And if you want more information, you can check my email. And here you have the Rainforest Foundation webpage that you can check. Until next time.
Great, thank you. I want to thank both.
Muy bien, gracias a ambos.
I want to thank both for their great use of data. This is a classic example of what we're talking about when we say the front lines. I mean, there's front lines meaning governments and companies who ultimately influence on the ground, but these are actually people on the ground protecting the lands that they call home. And so, as I was saying before, part of our vision here is that the Land and Carbon Lab can actually empower more and more people, those living in forests, but also the people that live in the grasslands and the wetlands, the savannas of the world, to actually protect and restore those lands that they call home. So now, for our final showcase of groundbreaking monitoring, I'm going to turn to my colleague, Nancy Harris, who's Land and Carbon Lab Research Director at WRI. You've heard how we in partners started with forests, but now are expanding to trees beyond forests, as well as all forms of terrestrial ecosystems. So we're getting better at monitoring the Earth part of Earth. But these ecosystems contain a lot of carbon, both in the vegetation and below the surface. And the role of these terrestrial ecosystems will play a fundamental part in tackling climate change. They are the nature in nature-based solutions. So you're going to hear from Nancy how we can now monitor the carbon stocks and flows from the world's forests, which cover about 1/3 of the world's land cover. So this is a pretty big deal here. Nancy, tell us more.
So as Craig mentioned, one natural extension of all this work going on to map the world's land cover is to translate what we're seeing in terms of land cover change into what they mean for climate change, because we know that governments and investors and NGOs and companies, we all need carbon monitoring information to pursue nature-based climate solutions. And once upon a time, people like Wanjira and Tom and Jorge, who we just heard from, and really everybody else in the world, we were kind of stuck with two main alternatives when it came to monitoring land's role in the global carbon cycle. The first was to send out field crews to set up inventory plots and measure the carbon stored there. And after several years, we'd send the crews back out to remeasure, and we could then estimate how carbon stored in vegetation and soils had changed over time. Now, that's certainly feasible to do for a single project location, particularly if you're planning to sell the carbon credits, but it's not feasible to do on every location on Earth. And so the other alternative we had for understanding how land contributed to climate change was to look at national statistics like these that get reported by countries to the Food and Agriculture Organization and the UN Framework Convention on Climate Change. But both of these alternatives, though, make it really difficult for everyday decision makers to understand how specific areas of land at all the scales we could possibly be interested in contribute to global climate change. And so now we've started to combine those inventory measurements that are collected on the ground with satellite imagery to produce much higher resolution maps like this of carbon stocks, or the carbon that's stored on land. And in the case of fossil fuels, that carbon is stored in geological deposits buried deep underground. But for land, the carbon is stored in the trees. And it's not just the trees, it's also in the limbs and the leaves that fall off the trees onto the ground and in the soil under the trees. All of this is storing carbon. And in fact, there's actually more carbon stored on land than in extractable fossil fuel deposits. But what's important in both of these cases is the carbon flows or fluxes. So in other words, what matters for climate change is the carbon that's going up into the atmosphere or getting soaked out of the atmosphere. So when we look at satellite imagery, we see forests are being cleared over time, and the carbon that was stored in those forests gets emitted into the atmosphere as carbon dioxide. So the land is losing carbon and the atmosphere is gaining carbon. And on Global Forest Watch, we see those locations of tree cover loss over the past 20 years. But now, thanks to those carbon stock maps that I just showed, we can also estimate the emissions resulting from that clearing anywhere in the world. And those emissions vary depending on where they happen and what caused them. So here in Western Paraguay, emissions were lower or lighter purple than from nearby forests in Brazil. And emissions were higher there because those forests were storing more carbon before they were cleared. So the darker the purple, the more carbon emitted. And that's even more apparent here on the other side of the world in Sumatra that Matt mentioned, where not only was the carbon lost from the trees, but also from those carbon-rich peat soils, which were drained, causing the soils that used to be waterlogged to now be exposed to the atmosphere and releasing carbon. But tropical deforestation is not the only thing that leads to emissions in this world. We also see emissions from wood harvest happening in the form of these very distinctive clear cuts here in the Pacific Northwest of the United States, and also emissions from wildfires like here in northern Russia. And so all of these emissions are happening relatively rapidly. So when we cut down trees or burn trees, it's an immediate large pulse of emissions into the atmosphere. So in the case of fire, like the photo on the left, that carbon may be emitted over the course of just a few hours. But it's really important to remember that trees not only emit carbon when they're cleared, they also sequester or remove carbon from the atmosphere as they grow. But relative to emissions, the timing of those carbon removals, as represented by the photo on the right, is relatively slow. And so the carbon benefits are stretched out over many years. So when we go back to that satellite record, we see a lot of land and a lot of forests like this. They don't appear to be changing much, if at all, over time. And so this is the case for most forests around the world, actually, even the relatively young ones where the tree canopy has already closed. So all of these forests are slowly gaining carbon, but they're pretty easy to ignore to focus instead on those visible changes that we can pick up in satellite imagery. So this example of a visually unchanging forest is back in Brazil. And when we zoom out, we can see emissions from deforestation happening all around that unchanging forest, just to the west of the river there. And this forest happens to be a protected indigenous community land. And so with the new carbon data we've produced, we can estimate emissions from deforestation using this map but we can also estimate the carbon that forests that remain standing removed from the atmosphere over time, gradually adding to the carbon stocks on land. And so when we select this protected forest to analyze on Global Forest Watch, we see that over the last 20 years, it removed more than 700,000 tons of carbon dioxide from the atmosphere every year, which essentially counterbalances the emissions of more than 150,000 passenger cars. So this is really the first time we can generate estimates like this of carbon emissions and removals associated with any forest anywhere in the world. And just like emissions, the carbon that gets absorbed within any given area of forest also varies based on the type and the age and the management and the location of that forest. So mangrove forests along the coastlines, like here in the Sundarbans of Bangladesh, they're really highly productive ecosystems. They absorb a lot of carbon relatively quickly. And the same is true for fast-growing tree plantations, like here in the Southeast United States. And if we go back to that wood harvest example I showed earlier in the Pacific Northwest, now instead of showing you those purple emissions from timber harvest, now you're seeing all of the forests in various stages of regrowth, all of which are absorbing carbon from the atmosphere. So with these new maps, we see that forests are both sources and sinks for atmospheric carbon. And when we combine them together, we can estimate a net carbon flux for any area of forest anywhere in the world. And so globally, over the last 20 years, we estimate that forests absorbed about twice as much carbon from the atmosphere as was emitted, meaning that globally, forests are a net carbon sink. But with these new maps, it becomes apparent that the monitoring data that we had to work with before that focused only on that one net global number, or even only on one net number per country, masks these really important local carbon dynamics. And we know that to have any chance of holding warming to 1.5 degrees, we need to both reduce emissions and increase removals on land. Those two things are additive when it comes to mitigation. And so we need a monitoring system that's able to track those two things separately so that we can see how we're doing on each side of that mitigation equation. So I'll close by saying that even though forests only cover about 1/3 of the world's land base, we're getting about 90% of that net carbon story here with these new data. But so we're already well on our way, but we're also kind of just beginning. We'll be working with partners to update and refine these maps with better data over time. And we'll also expand our scope to map carbon fluxes, not just from forests, but from all land, including things like the carbon that gets absorbed by all those trees and mosaic landscapes that John showed, and the emissions and removals happening in agricultural soils. And we'll deliver those data so that everybody who needs it can use it to monitor the climate impacts of all these pretty tough decisions we're going to have to make moving forward around how we manage the world's land. Back to you, Craig.
Wow, thank you very much, Nancy. I just want to emphasize to everyone here the groundbreaking nature of this, right? 1/3 of the world's land area, an estimated 90% of the world's terrestrial carbon fluxes, a 30-meter resolution, all carbon pools, going back to the year 2000 all the way up to today, and we're going to continue doing this year in, year out going forward. Huge contribution to nature-based solutions. And to give us a flavor of the importance of what Nancy just presented and why measuring terrestrial carbon matters to unlocking nature-based solutions, I turn to Maureen de Bezelaire, Group Advisor of Natural Capital for the bank HSBC, who shares this short video statement. Maureen.
First of all, I would like to thank you for giving me the opportunity to share my support to this initiative. Thanks, Laura and Rod, to allow me to do that, even broadcasted. What I wanted to say is to, first of all, remind that there's an urgent need to protect and restore natural capital, because there's no pathway to net zero without addressing these issues. And nature-based solutions are key, as they are designed to help both address climate and biodiversity crisis and contribute to sustainable development. Meanwhile, the fact is that only 2 to 3% of climate finance are dedicated to nature-based solutions. So how can we move this sector at scale? Well, to contribute to solving this issue, we have decided within HSBC to create a partnership with WRI and WWF. And that partnership is called the Climate Solutions Partnership. It's a 5-year philanthropic program. And one of its main focus is to identify and address the most significant barriers to scaling commercial investments in nature-based solutions. And we called it the NBS Accelerator, the Nature-Based Solutions Accelerator. Well, certainly the issue of having reliable, mainstreamable measurement and monitoring tools is key and one of our top priorities. So I'm thrilled to foresee the potential the data and innovations produced by the Land and Carbon Lab will bring to the sector. And I really look forward to see the outcome that is going to have on our ground projects we have selected to help them develop at scale. Trust in the fact that the projects are producing tangible improvements in nature and carbon is key for investors to allocate capital towards nature-based solutions. So together we are exploring options to build this trust. We hope for the Land and Carbon Lab to be instrumental on this journey. Thank you very much.
Thank you, Maureen. And as Maureen said, having credible, trustworthy data is critical for driving capital towards nature-based solutions. And now to bring this all home, it's my honor and pleasure to give the floor to Andrew Steer, President and CEO of the Bezos Earth Fund, the anchor funder for the Land and Carbon Lab. Andrew, we'd love to hear your perspectives.
Great, thanks, Craig. My goodness me, we've all been to many Zoom seminars, but this stands at the top. Absolutely stunning. Congratulations to all of you. And what a partnership, you think about it. I mean, the best data scientists, the best sort of technological geniuses. I mean, to listen to Matt Hansen, Rebecca Moore, and the rest of you, I mean, quite incredible. And then the users. I mean, whether Wanjira, whether Pablo and NDC partnerships, and how cool to hear from Tom and Jorge and how this is being applied in indigenous areas. Look, this is great, and congratulations to the WRI team for working. You haven't been at this new venture for long, although obviously it builds upon an amazing base that you had before. But Crystal and Nancy, John, and the rest of you, well done. Thank you. So for us at the Bezos Earth Fund, it's a delight that we are able in our modest way to be supportive of what you're doing. And what we're finding now is that it's going to be useful to us, just as it's useful to many other people. Each week, the more you think about it, the more applications there are. And even today, I've learned of some new ones. A couple of months ago, we announced at UNGA, we announced $1 billion for protection to support the new 30 by 30, 30% of the world's land and forest to be conserved. And we're going to be announcing in Glasgow specific grants for the Congo Basin and for the tropical Andes. Now, we're providing these grants to world-class organizations who in turn pass on a lot of the money to the people who really do the work, which are on the front line. But how do you know you're really getting what you thought you were going to get? Well, you ask Land and Carbon Lab to tell you. So all of the grants we make will now be sort of geo-referenced. And even more relevant will be the work we are going to be doing on restoration. And hearing from Wanjira today was really great. We're going to make a large announcement in Glasgow for landscape restoration over the next few years, starting in Africa and in the United States. Again, there are literally thousands of small implementers, all well motivated, but we need to have some kind of knowledge about what's actually happening. Well, for the first time in history, we actually will know that. And so for us, in a modest way, simply making us more accountable for how effectively we use our funding, this is going to be game changing, and think how much more relevant it is to everybody else. So that's remarkable. You think about it, the applications. I mean, Pablo today was talking about NDCs. We will be able to know whether or not the NDCs are actually being implemented with regard to the commitments, at least in rural areas. We've never really been able to do that before. That will be a real game changer. Think about, for example, the way our science-based targets are done. That will be relevant here as well. The whole non-zero pledges that people are making. And think about carbon markets. We're quite heavily involved in some of the voluntary carbon markets. We don't transact them ourselves, of course, but there is, as you know, a major debate going on between the project people and those that really believe there needs to be a more holistic approach, the so-called jurisdictional approach. This will enable us to know what's actually working. We should be asking everybody that's doing a voluntary carbon market to tell us what their georeferences are, and we'll be able to tell that. We're quite involved in what's called the LEAF Coalition, which is a group of corporates that are committing hundreds of millions, probably billions of dollars to voluntary carbon markets for nature-based solutions using jurisdictional approaches, the so-called art trees methodology. Again, we will be able to know, is this actually working? So look, I mean, this is, you just think about it for a moment. I mean, many of you live your lives every day, and so maybe it's not so stunning to you, but you think just how game-changing this is. I mean, 10 years ago, this would have been unthinkable. And as Crystal said, the data itself won't solve anything, but my goodness me, it enables us to make progress and have an accountability system that we never would have had before. So I take my hat off to you. It's been a wonderful hour and a half. Thank you, Craig, and back to you.
Great, thank you, Andrew. And on behalf of WRI, I want to thank the Bezos Earth Fund for investing in this vision. So, well, folks, there you have it. Land and Carbon Lab, from the frontier of data to the front lines of land use. The planetary need is there. You've heard Crystal talk about the land squeeze. We all know about the climate change challenge. We all know about the biodiversity crisis that we're in right now. And we've heard even today about the threats to indigenous peoples. So the planetary need is there. At the same time, the monitoring supply is emerging. You've heard a lot of that during today's sessions. Trees outside forests, the ability to monitor all forms of land and land use change, the ability to monitor carbon, now for 90% of all the carbon fluxes, as Nancy was describing, and all this at increasingly higher resolution and higher frequency. So the planetary need is there, the monitoring supply is emerging. At the same time, decision maker demand is growing. And again, we've heard about this a lot today. Governments, business, finance, NGOs, and now with Andrew, philanthropies, right? Philanthropists are interested in this type of data as well for ensuring accountability in terms of what's being invested in. So the time really is now to bring these three together. The global need, the data supply, and the burgeoning demand. Bring it all together to conserve, restore, and sustainably manage the world's land and its carbon. So with that challenge in mind, I want to thank the lab partners, our collaborators and financial supporters. I want to thank you, our audience, for joining today's event. And I invite you, if you're interested, to become engaged in the lab's big tent as a partner or as a collaborator. Please contact us. And as those in Glasgow next week will tell the world, the clock is ticking. So we must proceed at pace. So onward, my friends.